Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and the question belongs to paper 9709/42 for the session May June 24. Let's go through question number 6. It says three particles A, B, and C of masses 5 kilos, 1 kilo, and 2 kilos respectively lie at rest in that order on a straight, smooth horizontal track XYZ. Initially, A is at X, B is at Y, and C is at Z. Particle A is projected towards B with a speed of 6 meter per second, and at the same instant, C is projected towards B with a speed of V meter per second. In the subsequent motion, A collides and coalesces with B to form particle D. Particle D then collides and coalesces with C to form particle E, and E moves towards Z. And in the question A, they told us to show that after the second collision, the speed of E is 15 minus V over 4 meter per second. So what is the scenario? Actually, we can write here, look, first, suppose this is a straight horizontal line, okay? Here, there may be X may be over here, Y is at this stage, and Z is at this stage. And particle A is moving towards V. Particle A is moving towards V, B is at Y. Whereas C is lying at this stage at the position of Z, and which is moving towards B. So direction between A and C is opposite to each other. Let's start the solution. As they have told us that there are two collisions, so one after the other we will apply the concepts. And for finding velocity before and after collision, we just simply apply the concept of the conservation of the momentum. So first of all, we will find the velocities before and after the collision of the particles A and B. So let us start our writing. First one is MA into UA plus MB into UB is equal to mass of particle A into final velocity of A plus mass of particle B and final velocity of B. So what is the mass of the particle A? Mass of the particle A is 5 kg. So it is 5, and initial velocity of A was 6. It is 6 plus mass of the particle B is 1 kilo, and initial velocity of B was 0 because it was at rest. All of these three is at rest in a order. A is at X, B is at Y, and C is at Z. Particle A is projected. So about this at rest, look at this. It is written lie at rest. All the particles initially was at rest. Then A was projected towards B. So B is at rest because B wasn't in any motion. Now let's talk about the final velocity. Mass of particle A is 5 kilo, and particle velocity of particle A after collision, it was after colliding A and B, they form particle D. Look at this. It is written here, they form particle D. So this is actually final velocity of D. Plus mass of particle B is 1, and after first collision it formed particle D, so it is nothing but the final velocity of particle D. Well, if we simplify, it is going to be 30 equal to 5 plus 1, it is 6 into velocity of d. So what will be the velocity, final velocity of particle d? It is going to be 5, 5 6 is 35 meter per second. So this has been the final velocity of the particle after first collision. Okay, now we will write for the second collision. After the second collision, after second collision, after second collision, we will apply the same concept to find the velocities collision. Okay, after second collision, same concept means mass of particle d into initial velocity of d plus mass of particle c into initial velocity of particle c is equal to mass of particle d into final velocity of d plus mass of particle c into initial velocity of c. Well, so let's see what was the mass of particle d. Particle d is actually nothing. Look, particle d is the combination of total mass of a and b. It is written over here. A collides and coalesces with b. So a plus b is nothing but 6. So 6 into, or 6 into initial velocity of particle d we have already obtained. It was nothing but 5. So 5 plus mass of particle c was 2. Mass of particle c, here it is written mass of particle c is 2. Okay, so initial velocity of particle c, it is mass was 2, and initial velocity of particle c was, it is written c was projected. C is projected towards B with the speed of v meter per second. C is projected towards B with the speed of v meter per second. Here, initial velocity is v and mass of particle c is 2. Okay, so let us write this. Mass of particle c is 2 and initial velocity was v meter per second, equal to mass of particle d. Mass of particle d is nothing but the combination of particle a and b, which is 6. 5 plus 1, that is 6, and into initial final velocity. Final velocity is to be obtained, and look at this. Final velocity is after the collision. Actually, d then collides with collides and coalesces with c. So it is c plus d together. It is now e. The name of the new particle is E. So we will write here mass of D was actually a combination of particle A and B, which is 6, and initial velocity, final velocity of particle D is to be obtained, which is now particle E. Velocity of E plus mass of particle C is how much? It is 2, and final velocity will be just the velocity of E. Okay, and here look at this, we have made a great mistake over this. Look at this, it is particle c. Let's see, particles, the direction of particle c is, c is moving, a is projected towards b with the speed of 6, and at the same instant c is projected towards b. Look at this, c's direction of c is this way. This is the direction of C. B was moving towards C, C was moving towards B. So the direction was different. That's why we cannot use the addition symbol here. Instead of addition, what will we use? It is no more addition, it is subtraction, because the direction of the motion was different, opposite to each other. So let's write here negative symbol, and definitely this is also going to be a negative symbol. Okay, it is negative symbol. After that, if we simplify, what is it going to be? It is going to be 30 minus 2v. 30 minus 2v. And here 6ve plus 2v. So it is 8ve. Or let me write just beside this. Or what is it going to be? Okay. It is or 8ve. 8 velocity of particle E is equal to we can directly write this. Let me erase this step. So if we isolate velocity of E, velocity of E is equal to what? If we isolate, 8 will go as denominator and numerator is what? 30 minus 2v. 30 minus 2v. 2v. Hence, our velocity of particle E after second collision is going to be what? If we cancel out every quantity by 2, it is going to be 4 and 15 minus V, meter per second. Meter per second. Meter per second. And they have told, sorry, they have told us to show that the final velocity after the second collision is 15 minus v meter per 15 minus v over 4 meter per second. So that's all about the solution to the first part of the question, and we have already shown. So let us write shown. So simply we have just applied the same concept of the conservation of momentum in two steps because there were two collisions. Let's see what the immediate next questions say. The immediate next question says the total loss of kinetic energy of the system due to two collisions is 63 joule. Use the result from A to show that V is equal to 3. So it's the concept is what? The loss of total kinetic energy, and we can easily apply the concept of the change in kinetic energy. So loss of energy, first of all we will write after first collision, as there are two collisions one after the other, we will continue writing. So after first collision, first collision after first collision, loss of kinetic energy, loss of kinetic energy is equal to what? What is the formula for loss of kinetic energy? Is equal to, as there are two particles, we will have to write change in the first collision happened between particle A and B. So as this is actually loss of kinetic energy, so it must be negative. It will produce negative result. So change in kinetic energy after collision of particle A as well as change in kinetic energy of particle B after collision, particle B after the first collision. Okay. So how will we write this? And you know the formula for, can I write this just a little bit over there? Okay. What is the formula for change in kinetic energy? That is half m v square minus, again this is the final velocity of, means a difference between the velocities of A, minus half m difference between the velocities of B. So little by little let us calculate. I think I can write this just at the left side so that I have sufficient space. Okay. Let me write this. No, let me continue over there. So one after the other, it is going to be negative half. Mass of the particle A was nothing but 5. Let us see. It was mass of the particle A was 5 and particle B was 1. Okay. So it is 5 and 1, and initial velocity of A was 6 and final velocity was 5. Let's say it was final velocity after the first collision was 5, initial velocity of A was 6 and initial velocity of B was 0 because it was at rest, and final velocity of particle B after first collision is same, means 5. So we are going to write over here mass of particle A was 5 and final velocity of particle A after collision was, as we have seen, it was how much? After first collision it was 5 meter per second. This is the velocity after first collision, common velocity of the first after the first collision. So it is 5 squared, and initial velocity was 6, as we have seen, 6 squared minus half of mass of particle uh, B was nothing but 2, isn't it? No, not 2. I think particle V, mass of particle V was 1 kg. Yes. So it is 1, and final velocity of particle B and A, it was combined and coalesces, so it was 5 squared. Initial velocity of particle V was what? 0, because all the particles initially was at rest. So it is going to be negative half into, if we subtract this, it is going to be 25 minus 36. Remember, here I want to clarify one concept, that when we apply the change in kinetic energy formula, final velocity, it is actually v square, means the difference between the velocities. Final velocity must be written at the beginning, so it is nothing but the difference between the two velocities, the velocity before the collision and velocity after the collision. But the final velocity, the velocity after the collision, should be written at the beginning. So after the collision of the, after the first collision, final velocity was 5 square. That's why we have written here 5 square. And it is going to be now minus 5 into minus 11. 36 minus 25 means 11. So negative 55. Negative 55. And here it is going to be half of just 25. Well, so what is it going to be? It is going to be 2 over minus minus plus 55 and minus, that is 25 over 2. So ultimately what is it going to be? 55 over 2 means 27.5 and 25 over 2 means 12.5. So from 27.5, if 12.5 is subtracted, it is going to be actually 15 joule. 15 joule. So the loss of energy after first collision was 15 joule. Now we will find the loss of energy after the second collision. Can I write it just over here? Yes. I will write here after the second collision, okay, with the different ink. After the second collision, or let me find the space where there are a greater space. Yes, I can write on the left side of this. After the, after the second collision, we will apply the just same concept. Okay, change in the loss of energy, loss of kinetic energy, energy equal to what? Change in kinetic energy after the second collision. The collision happened between the particle C as well as particle, as this is loss of energy, so it will be negative. So negative change in kinetic energy after the second collision between C and D. C and D. Well, so the same formula we are going to apply, half mv square. M of the mass of particle C. Mass of particle C was, how much was the mass of particle C? It was 2. And so mass of C is actually 2 kilo. So it is 2 kilo. And final velocity, we know that v square means the final velocity minus initial velocity. And final velocity after the first collision, between after the second collision, final velocity was what? For both C and D, it was same. How much was the final velocity? Yes, the final velocity was this. This was our final velocity, 15 minus v over 4 for both C as well as D. Well, so let us write that final velocity is 15 minus v, 15 minus v over 4 square minus initial velocity. Initial velocity of C was nothing but v. Let's see what was the initial velocity of C. Look, C is projected towards B. C is projected towards B with the speed of v meter per second. With the speed of v meter per second. So initial velocity of C was v meter per second, whereas initial velocity of D. Look, initial velocity of D was 5 meter per second. So we are going to just substitute these values. So initial velocity of C was nothing but v square, v square. Okay, we have completed one of the parts, minus half mass of particle D is nothing but 6, because D is actually the combination of particle A as well as particle B, which was particle A and B was, A was 5, B was 1, so 6. And final velocity of both C and D was same, 15 minus V squared, 15 minus 15 minus V over 4 squared. 15 minus V, 15 minus V over 4 square minus initial velocity of D was nothing but 5 square. Well, then let us do the simplification. Well, it is going to be 1, so negative, and if we simplify this, it is going to be 4, not 4, it is going to be 16 because square, so it is 16. Okay, then 15 square means 225 minus 2 15, 2 15 is 30, 30 v plus v squared minus v squared. So first part has been completed, then the second part. If we divide 6 by 2, so this is 3, and similarly this is going to be 16 over 225. It's exactly same, 225 minus 30v minus 30v plus v square, and finally minus 25. 5 square means minus 25. Okay, so this is what this step is. After that, it is going to be well, if we simplify, let it be negative symbol in front of everybody. 16, so 225 minus 30v plus v square and 16v square. It is going to be negative 16v squared minus here if 16 is over here, so if we multiply by 3, it is going to be 675. 675 minus 90v plus 3v squared. At the same time, if we multiply 25 by 16, it is going to be 400, and 400 threes are actually 1200, so it is going to be 1200, but it's no more negative symbol, it will be positive symbol. Sorry, it should be negative symbol because we didn't dissolve the symbol, so it is minus 1200. 1200. Well, after that it is going to be 16, that is 220, negative 225 minus 30v and then negative 15. Sorry, it will be negative and negative, it will be positive. Positive 15. It was 16v square, not 5. It is just v. Okay. So 16 minus 1 is negative 15, negative, negative, positive 15v square. And here it is going to be, if we do subtraction, this 1200 minus 675, so it is going to be just 25 less than 6, 575, and minus minus plus. Plus 575. Well, sorry, not 575, 525. It will be 525, 525. Then minus minus plus 90v. After that, plus minus minus 3v square. Well, after that, what is it going to be? I don't have space to write over here. Okay, I can just write over here. Equal to 16 is the denominator, and if we simplify the v square, what will happen to the v square? 15v square minus 3v square, so it is actually 12v squared. 12v squared, 12 12b squared. Sorry, then minus 30v plus 90v, so it is going to be, sorry, it should not be minus because minus and minus, it will make it plus. So plus 30 and plus 90, it is 120, plus 120v, plus 120v, and then 525 minus 225 means this is 300, minus 300. Well, after that it is going to be, so this is the loss of kinetic energy after second collision. For first collision it was 15 joule, and for second collision it is just, let me write over here, joule. So this is the total loss of energy, kinetic energy. Now we will write here that loss of total energy. Okay, loss of total energy is already given. How much is the loss of total energy? They have written here that loss of total loss of the kinetic energy after two collision is 63. So we will just write it down using a different ink. So total loss total loss. Total loss is equal to 63 joule. Well, so first, the loss of kinetic energy after the first collision was 15 joule. This is 15 joule. So we will write 15 plus 15, and the loss due to the kinetic loss of kinetic energy due to the second collision is this. It is 12 v square plus 120 v minus 300. 12 v square plus 120 v minus 300. 12 v square plus 120 v minus 300 over 16, and right side is 63. So from 63, if we subtract 15, it is going to be 48. So 12 v squared plus 120 v minus 300. If we subtract 15 from 63, it is 48. 48 into 16. So 48 into 16, let me calculate this. It is going to be 768. 768. Well, if we form a quadratic equation, so 12 v square plus 120 v, then it is going to be minus 300. Will it be minus 300 or plus 300? I think it should be plus 300. Why should it be plus 300? Negative 225. Yes, it was. Look at this. These are the two quantities. From 525, if you subtract negative 225, so it is positive symbol. So it's positive 300 instead of negative 300. Yes. So it was positive 300, positive 300. Now, if we subtract 300 from 768, it is going to be 468 equal to 0. And all of the whole of the expressions can be divided by 12. So it is going to be v square plus 10v by 12. If we divide, it is 3 12 are 36 and 108 9. Well, so v square plus 10v minus 39. Then if we factorize this, v square plus 13v, 3 13s are 39, so minus 3v minus 39 is equal to 0. Let us take something common. If we take v common from the first factor, it is v plus 13, and the second factor is going to be v minus 3 equal to 0. Hence our v is going to be 3 since v is greater than 0. Well, after that they have told, let us see what did the question tell us. The question told us, show that, use the result from A to show that our v is 3. V should be 3. So we have already shown that our velocity, final velocity is 3. So it has been shown. We have shown. I think you have understood the solution, that for finding total loss of kinetic energy, stepwise we have done this. First we have found the loss of kinetic energy after the first collision, which was 15 joule, then the loss of kinetic energy after the second collision was 12 v square, 12 v square plus 120 v plus 300 over 16, and they have told that total loss of the kinetic energy after two collision is 63 joule. So we have just formed an equation over here. After that, finally we have got that v equal to 3, which was supposed to be shown. That's why we have shown. Let's move on to the immediate next question. The next question says, let's move on to the immediate next page, page number 3. The next question says, it is given that the distance xy is 36 meter and the distance yz is 98 meter. Find the time between the two collisions. Okay. So first of all, what will we show, or let us draw the scenario. Suppose this is the straight line. Okay. This and this one. This one is xy and the second phase is yz. A started from x and it collided with B, and after that it has been termed as D. After coalescence, they have been termed as D. Okay. Then C from Z, C was just moving towards D, and after that they have named as E, but it is not appropriate in this way. Suppose C was, the distance between x and y was 36. It was 36 meter, 36 meter, and distance between y and z was 98 meters. Well, let's say after the first collision, D reached up to this, and since the beginning C was moving towards D and it traveled, this is the distance. Well, so one after the other, first let's see what is the time taken by A to reach D or B, that means to collide B. And for this, simply we will apply the concept of the Shubert formula. Shubert formula is SA. We can write SA, the distance traveled by A, is equal to, UT plus half AT square, because we are going to find T. Now, SA is nothing but actually 36 meter. Okay. So, it is 36 equal to initial velocity of A. We have not forgotten that initial velocity of A was what? Initial velocity of A was, it is written clearly over here, initial velocity of A was 6. This is initial velocity of A is 6 and initial velocity of C was V meter per second. V was found to be 3. We have already found that V was 3. So initial velocity of A was 6, whereas initial velocity of C was 3. So let them be substituted over here. If we write here, initial velocity of A was 6, so it is going to be 60 plus, now acceleration. Actually, look at this, there is no acceleration acting on this. Let's see the question again. It says, what does it say? It say that three particles A, B, C of masses 5 kg, 1 kg and 2 kg respectively lie at rest in that order on a straight smooth horizontal loop. This is horizontal smooth track. So there is no frictional force at all. At the same time, there is no external force also. Look at this. Particle A was projected. A was projected and C was also projected. That means no external force has been applied to have the acceleration or resistance to motion. So I think you have understood. So the clue is there is no external force applied on any of the particles. At the same time, the surface was smooth. That's why there was no resistance to motion at all. That's why there will be no acceleration at all. It's just initial velocity. So there is no acceleration because the surface is smooth, as well as there is no external force applied. Hence our T is going to be T of A. That means A took 6 seconds to collide with B. Now the second phase is from Y until Z. Y until Z. Now after first collision, A, B together formed particle D. So let it be written after first collision. After first collision, let me change the ink. It may be black. After first collision, first collision. After first collision, what happened? AB together has formed D. So we will write SD is equal to UT plus half AT square. We are applying the same concept. Now SD is actually how much is the distance traveled by D. Suppose they met and collided at this point. Okay, so this is actually 98 minus something, it may be X, and it will be 98 minus X. Well, so we will write initial velocity of D. Initial velocity of D, for this we will have to go back. Look at this initial velocity of D after the first collision. After the first collision, initial velocity of V was 5 meter per second. So it is 5 meter per second. For D, it is 5 meter per second, equal to 5 t plus, so is the second value of acceleration. Actually there is no acceleration at all because the surface is smooth and there is no external force applied on this, so there is no resistance force at all. That's why it is 0. So ultimately it is going to be 5t. Okay, 5t, let it be 5t. We may leave this as equation number 1. This is the time taken by D to meet C. Now the third part is the distance traveled by C. Distance traveled by C is the same concept, ut plus half at squared. So let the distance be 98 minus x. After that, look at this here, 5t. Okay, we may write it as x or x, and this one is also x, and here it is going to be 98 minus x or 98 minus x. Let us write it is 98 minus x equal to initial velocity of C. Initial velocity of C was v and v was 3, we have already shown. Now time. The question is, will the time will be same as it has in case of A? It is absolutely not. Look at this. If we look at the scenario, A collided B after 6 seconds. After 6 seconds, A reached up to D. Look at this. So it has taken 6 seconds. After 6 seconds, D started its journey. But what about C? C, since the first moment, together A and C at the same instant they were projected towards D. So what happened? A took 2 seconds, but C 2 seconds to reach D or collide with D and collide with B to form particle D. But C was still in motion. That's why C has already taken 2 seconds more. That's why for the case of C, remember we'll have to write t plus 2 because this journey has started from y. This journey has started from y after first collision, but C was continuously moving before first collision. That means since the first moment. So for C took actually 2 seconds more. That's why we'll have to write here, instead of, in case of C, we will write t plus 2. T plus 2 plus, there is no acceleration at all because surface is smooth and there is no external force. That's why there is no resistance even. That's why it is 0. So what will be our equation? We can write that this may be written as equation number 2. This is our equation number 2. Equation number 2. Then by forming this simultaneous equation, this equation, simply what can we write? The total distance traveled by them, is what? First equation was 5t. So 5t plus, we can write equation 1 from equation 1, or equation 1 minus equation 2, whatever you take. Okay. So 5t plus, this plus 5t plus 3 into t plus 2, and the total distance they have traveled is 98. Actually, x plus 98 minus x is actually 98. Well, so what is it going to be? 5t is 5t plus, sorry, we made a great mistake. It was not 2 seconds. T A took 6 seconds, so it will be t plus 6. T plus 6, not t plus 2. It is, so 5t plus 3t plus 18 plus 18 is equal to 98. Well, so 5t plus 3t, that is 8t. If we subtract 18 from 98, it is going to be t. So t is equal to how much? 10 seconds. That means since the beginning till the end, the time taken for both the collisions, it is 10 seconds. So they have told, look at this, the question told us to find the time between the two collisions. So first collision occurred after 6 seconds, okay, and second collision occurs after total after 16 seconds. So t is actually 10. That means t was what? T was the time after the first collision until the second collision. So please don't get confused. Actually, C took 10 plus 6, 16 seconds. C took 16 seconds. Sorry, A took, yes, C took 16 seconds. And A took 6 seconds to collide first time. So 16 minus 6 is actually 10. That means total time difference between the time of two collisions is actually 10 seconds. That means C took 10 seconds to reach at this stage, means X, and D also took 10 seconds to reach at this stage. At the same moment, after the first collision, it took 10 seconds. So first collision, but A took 6 seconds for colliding first, and C took 16 seconds to collide D. That means difference between the time is 16 minus 6 is equal to 10. So simply we have found the time was 10 seconds after the first collision. That means they told to find the time between the first collision and second collision, and which is 10 seconds. So after 10 seconds, D collided C and C collided D. But C took actually 16 seconds, because since the beginning C was in motion. So 10 seconds plus 6 seconds earlier. So total 16 seconds were taken by C to collide D. But D took only 10 seconds after the first collision. So finally our distance between the time of two collisions is 10 seconds. Let's see the next question. The next question says find the time between the instant that A is projected from X and the instant that E reaches Z. Okay, now the scenario is, so the next question says find the time between the instant that A is projected from X and the instant E reaches Z. So one after the other, let's say first A took, look at this, we have already found here, A took 6 seconds to reach D. So first instant 6. Then X took, I mean this D, the first particle and second particle, D took 10 seconds to reach at this point X. Okay. So let us see the distance traveled by D. Okay. It was, the time was 10 second. Distance traveled by, distance traveled by D before second collision, before second collision collision. So what is the distance traveled by D before second collision? Look at this, total distance was how much? It was 98 from D to C, means for finally it has become E. Okay, so it was X is equal to, this is our X equal to 5t. Okay, this is the distance traveled by D before second collision, so 5t, and it traveled for 10 seconds. We have obtained here 10 seconds, and the velocity of, I mean the distance traveled by D before second collision was 5 into 10. 5 into 10 means 50 meters. So it was actually 50 meters. This is going to be 50 meters. This distance of X is 50. D moved forward 50 meters. So it will be written that it is 50 meters. 50 meters. 50 meter. Okay, now if D traveled 50 meters after second collision, now D, there is no existence of D, it coalesces and form E. So E traveled from 98, if we subtract 50, there remains only 48. Now there remains only 48 meters left. 48 meters, it is actually now 48 meters left. Okay, so 48 meters were traveled by E. Okay, now let us see the time taken by E. Okay, we can write S E. S E is equal to the same concept, U to Schubert formula, UT plus half AT square, and the distance traveled by E we have already shown that 50 meters was traveled by D and rest of them was traveled by E. That means the coalesce of all three particles. So it is just 48. And initial velocity of E was, let's go back to this. It was, okay, initial velocity, I mean velocity of E. Look at this, velocity of E was 15 minus V over 4. So V was found to be 3. V was 3. So 15 minus 3 means 12. 12 over 4 means 3. So velocity of E was 3. It was 3t. 3 into t plus, as there is no resistance force and it was projected on a smooth surface, it is 0. Hence our t is equal to what? 48 divided by 3, that is 16 seconds. 16 seconds. 16 seconds. So total time we can write here. Total time, they have told us to find the total time. Total time taken. Time taken is equal to, look, first A reached D within how long? This is 6 seconds. So first there were 6 seconds. After that D reaches at this point taking 10 seconds. We have got it was 10 seconds. 10. After that, from this distance E reaches Z. E reaches Z taking 16 seconds. 16 seconds. So total how much is the time since the beginning? It is 32 seconds. That is the total time taken by all of the particles to reach Z. So that's all about the solution to question number 6. It is a little bit lengthier but not difficult at all. Let me show you the first page. It was the solution to question number A as well as B, and the question number C and D have been solved over here. So I think you have understood as much as I could have explained. Totally, all the particles took 32 seconds to reach the position of Z. Thank you all. May Allah bless you with all good knowledges. Fi amanillah.